Hey everyone, so this is Miss Notaro. You're basically watching this video because you were either absent today in class or you weren't paying attention and need a little more clarification for your homework. So basically, I'm kind of going to just go over exactly what we did in class, starting with the warm-up. I have the calculator on the right-hand side of the screen. That way you can see exactly what I am doing. Okay, so a skydiver jumps from an airplane and an attached microcomputer records the time and speed of the diver for the first 12 seconds of the diver's freefall. The data is shown in the table. So basically, in the warm-up, you're being asked to now find the equation for the line of best fit, which is a previous lesson we have already learned. And then we're going to round both of those coefficients to the nearest tenth. As well, then we're then going to determine the correlation coefficient and round it to the nearest hundredth. Now, correlation coefficient is what we learned about yesterday. Now, the correlation coefficient tells us whether this data set here, and let's say, okay, so my pen is working, the data set is good or is it bad? So we are going to use the computer on the right-hand side. So my computer's turned on. So what I'm pressing is I press Y equals. I don't press Y equals. What do I press? We have to put this data into the calculator. So we press stat and then we press enter. And basically what we want to do now is we want to enter the two different lines. This is my X and then the bottom is my Y. And our L1 acts as our X. So I'm going to put 0, 2, 4, 6, 8, 10, and 12. Okay, I then move over to the right so I can get to L2, and I put our speed, our Y values. 0, 25, 46, 60, 68, 72, and 74. Okay, you know you put them in correctly if you have your last X and Y's are paired up together. Okay, so we have all of those in there. So now we want to get the equation for these. So we go back to stat, but instead of editing anything, what we want to do is we want to calculate an equation. So we move over to the right, and instead of edit, we move over to calc. Okay, calc for calculate. Okay, and what we're looking for is the line of best fit, which we also know is called the linear regression. So if you go down to number 4, it says lin reg, and then it has the ax plus b, just like a line. Okay, we usually see it as y equals mx plus b. In the calculator, they use a for the slope. So you press enter, and you press enter again, and as you see, it says y equals ax plus b, where A is 6.035, so on, and B is 13.07, so on. So we want to round both of these coefficients to the nearest tenth. So what we're going to write is we're going to write y equals A, we're going to make 6.0 x, and then plus 13, and we're going to round up, so 0.1. And that is our linear equation. So now we need the correlation coefficient. If you remember from yesterday, correlation coefficient is the R value. Now right now, looking at my calculator, there is no R value. So what we have to do, now some of your calculators are already programmed to have the R come up. If they are not though, you do have to turn the diagnostics on the calculator. And to do that, you're going to press second and then 0, because right above 0 it says catalog. So we're going to go through the catalog, and we're going to go down to, and we're going to go down to D. So it's easier to just press alpha and then D, and then we scroll down to diagnostic off and diagnostic on. So what we want to do is we want to press enter and then enter again, and as you see it says say done. So now if I go back to stat, calculate, same thing, doing literally the same exact thing, linear regression, get that line. Okay, now as you see, my A and B are exactly the same, 6.035, and B is 13.07, but now we have the R squared and an R. So our correlation coefficient is the R value. So here we want to round our correlation coefficient to the nearest hundredth. So we're going to put R equals, and then we're going to write, and now it's R, not R squared. Okay, so we put 0.94. Okay, we round up here, and there is a decimal in there. Okay, so now we have those two things. Oops, I don't know what I just did. Erase that. Okay, so let's change colors. All right, so now after that, it says, based on the correlation coefficient, characterize the fit as a positive or negative, and how strong is it? So looking at 0.94, okay, we said yesterday, the closer you are to 1, the stronger your correlation is. So this would be what we call a strong correlation. And it is also positive because it is a positive number. Okay, so that is in regards to our R value. Strong, positive, and you want to write a complete sentence, but I don't really have the room. That says correlation. I know, very sloppy. I'm very sorry. Okay, so the last thing in the warm-up, it does say to create a plot. So hopefully this would be a lot easier and a lot faster. You know, you're doing it on your own. You're not having to explain it. All right, so we want to create a plot, and then we want to sketch it here. So I'll do that in blue. So we go back to our calculator, and we're just going to like clear it. Okay, you should all have your stat plot on already. Go second, and then y equals. Okay, mine has been cleared, so I'm going to turn it back on. It's on now. What I'm going to do is I'm going to go to zoom, and I'm going to go to number 9 because 9 says zoom stat, and what that means is we're going to zoom in and on our statistics that we just entered into the calculator. I press enter, and there you see our scatter plot. So I'm just going to sketch that over here on the left-hand side. Okay, I've got my Y, I have my X. Okay, so these aren't going to come out too nice, but, you know, I'll do the best I can. As you see, they are going up from left to right. They kind of start to curve a little bit, as you see here. There are 6 points. I don't know why my last point is not coming up. It does start to curve a little bit. We're going to actually get into that into our lesson today. But if I was to draw a line of best fit right through, okay, it is going up. Now, that's obviously not the exact line of best fit. That is just me drawing a line. But it is going up from left to right. It is positive. It is increasing. So, yeah, strong positive correlation. Okay, so now what we're going to be doing in this lesson is we're going to be talking about, or what we did talk about in this lesson, either you missed it or, you know, you just want to recap. So in the last lesson, we saw how, and I don't know if I'm going to be able to write in here that nicely, but I will try. In the last lesson, we saw how the correlation, yeah, no, this is not going to be that pretty. Correlation, coefficient, measures the predictability of the model or how well it will do in its predictions. It's also known as the R value. And although the R value is excellent measure, it does not tell us whether the model is appropriate. Oh my goodness. If you're confused on how to spell and you can't read what I'm writing, please look it up in a dictionary. Okay, so it does not tell us whether the model is appropriate, only whether it does a good job at predicting. Oh my goodness. There we go. Okay, so it's just predicting. Is it a good, strong correlation, or is it bad? You know, it's just predicting. It's not really telling us anything exactly. And we saw that yesterday. Our values, we said if they were closer to 1, it was a nice, strong, basically almost straight line. And if it was negative, okay, you know, same thing, -1, it would be a strong negative line. However, if it was like 0.54, that's gonna be a scatter plot. That's like crazy. Okay, so today what we're going to be examining is the residuals. And that's an I. Residuals. and the residual graphs. And I'm just gonna residual graphs. Okay, to determine a linear model. So basically, residuals are what is going to tell us, is this graph appropriate for what I just did, what I see, or is it not? Okay, and the way we find a residual is we take the difference, and hopefully everyone remembers, anytime I say difference, I'm not saying compare and contrast, okay? That's in English. Difference, we're subtracting. We're going to be subtracting the observed value, and then we're going to minus the predicted value. Okay, so the observed is what we've been given, and the predicted value is what we're going to actually find. Okay, so if we go to the next page, we have exercise number 1. And make this a little smaller. Okay, so exercise number 1, use the same data from the warm-up, so that's nice. So we don't have to really change any data in our calculator as of yet. To fill in the table with the predicted values rounded to the nearest integer and the residuals for each data point. Okay, so we're going to be finding some information here. So we're going to go, I'm going to grab some blue. Okay, so we want to first find the predicted value. Okay, so that's right here. Oh my goodness. That's right there. So the predicted value, okay, these are, once again, I said in the do now, the warm-up, this is my x, and this is my y. Okay, so from the warm-up, we saw that we have an equation y equals 6.0 x plus 13.1. So they observed that after 0 seconds, there was 0 speed. Okay. What we're going to do is we're going to take our equation and we're going to go y equals, and we're going to find the predicted. Now, what I mean is we're going to go 6.0 times, and instead of, we're going to put our x's in. These are my x's. So I'm going to put in 0, and then I'm going to add 13.1. Now, you could do that on your calculator. Hopefully, you can do some of these in your head. But remember, you can put everything right into your calculator. 6.0 times 0, use parentheses just in case you get negatives, plus 13.1, and that gives us a nice 13.1. So I'm going to put that 13.1 right in here. 0.1. I'm so sloppy. I'm so sorry. Okay. So now to find the residual, and the reason I went 13.1, okay, it says nearest integer. Okay, and then the residuals. So now to find the residuals, I just said before, okay, it's the difference between the observed and the predicted. So our observed was 0. Our predicted is 13.1. So now I do 0 minus 13.1. That equals negative 13.1. So that is our residual. Okay. So what that means is, now the original problem, okay, was talking about a skydiver, okay, jumping from an airplane, and they attached a microcomputer to see the time in the seconds. Okay, so our equation is basically saying that after 0 seconds, they were at, 13.1. So this is basically showing me how off. This is basically showing me how off it is from the actual observed time. Okay, so let's do another one. Okay, so I'm going to do number 2. Okay, so I'm going to go, I'm sorry, move this over. Okay, so we're going to do 2. So we're going to go y equals 6.0 times 2 plus 13.1. So y equals our predicted value equals, so 6 times 2, which you should all know is 12, and 12 plus 13.1 is going to give me, make sure you put the dot, 25.1. So I'm going to put that in here. So I'm going to put that in here, 25.1. And now we're going to do some subtraction so we can find the residual. So our predicted was 25.1. And our observed is just 25. So these are not that far off from each other. 25 minus 25.1 is just going to be a negative 0.1. 0.1, and it is a negative. Okay. So there you go. What I want you to do now is I want you to fill in the rest. Pause this. Okay. So hopefully you pause this and you figured it out on your own. I'm just going to write in the numbers that you should have got. So 37.1, 49.1, 61.1, 73.1, and 85.1. And then once you do the subtraction, so 46 minus 37.1 is 8.9. Okay, and I'm just going to fill these in. Okay, so we have now found all the residuals. And that is it. So those are your residuals. Now, I did talk about how we have the residuals and the residual graphs. And really what the graphs is that's going to be able to tell us whether this is an appropriate fit or not. So I'm going to look at the next part of the question. Not the next question, but the next part of the question, which says sketch a plot of the residuals below. Your teacher will need to show you how to do this on the graphing calculator. So make sure all your scatter plots and equations are off. So let's look at the calculator. Now we're going to clear. Make sure I go to y equals. Make sure I clear that. Nothing's there. Okay, so what we're going to do to graph this now, we are going to go second and then y equals. Okay, just like how I had turned this on earlier. So now if you go here, it shows that it is on. However, what this is we have a scatter plot, okay? And then we have list 1 and list 2. So we're no longer looking at list 1 and list 2 because we just found the new residual point. So we don't want to graph the same thing we did in the warm-up. So what you need to go do is you need to go down to Y list, okay? You see how it's like blinking with an A? What you need to do here is you need to press second, and then you need to press stat. And that's going to bring you to a list. So it already said we had list 1 and list 2. Okay? What we want is we want the resid, and that's number 7. Resid stands for residual. So I press enter. So now I have x1 is my x is my L1. My y is going to be my residual. So now, same thing. You're not just going to go to graph. You got to go zoom and then down to number 9, which is zoom stat. Okay, we want to graph the statistics. And as you see, this is our new residual. Now, that's not the same scatter plot we got earlier. Okay, so I'm going to sketch this. Okay, I see I have my y. And then I have my x-axis in the middle, though, you know, kind of like goes right there in the middle. So we've got numbers, negative and positive numbers. So we have positive and negative numbers on our y-axis, but we really only have positive numbers. We don't really see any of the negative numbers. Okay, so I'm just going to kind of graph this a little bit, get something pretty thick. Okay, I've got a point here. One right on the y-axis, one above, one a little higher, lower, right below, and then really low. Okay, so as you see, what you should notice about this is that this just made like a parabola, right? Now, if I was to, sketch. This looks like a problem. So this is actually not an appropriate graph. Okay, now earlier in the warm-up we said that it had a strong positive correlation because it was going up from right to left. It was increasing. However, looking at this, okay, this follows a very distinct pattern. And when you have residuals and when you are looking at residuals, we don't have patterns. So that's something, so you might want to jot down, okay, pattern, and let me get like a different color. So pattern, okay, patterns do not, so patterns are not, that says not, are not appropriate fits. So when you are graphing a residual and you see a pattern, it is not an appropriate fit. A good fit looks like you've got some up, you've got some down. Okay, just like a scatter plot. Okay, a scatter plot, we say it's strong if it's all going up, right? If it's increasing from left to right, all the points are scattered around it. Okay, you want the same thing for residual. Okay, this line is basically like our line of best fit. It is. It's saying, okay, what's the distance between these points? So you want to continue to have a scattered-like graph when you are graphing your residual graph. Okay, so in this question, going back to number 5. Okay, it asks, do the residuals show any distinct pattern? Yes, it does. So no, it is not a good fit.